Hello students, welcome to my YouTube channel. In this video, we will solve all the questions of exercise 13.2. In these exercises, all the questions are related to independent of events. So first let me explain you the concept of independent events. So what do you mean by independent event? So suppose A and B are two events. A and B are two events associated with same random experiments. Then when we call these two events are independent if the probability of A given B is same as probability of A. That means the occurrence of B does not affect the occurrence of A. Or we can write as probability of B given A. B given A is same as probability of B. That means the probability of occurrence of A does not affect the probability of B. So from this two definition we can write this. We know probability of A given B equals to probability of A intersection B divided by what is given B. So probability of B. We know this definition from conditional probability. Now we will apply this here. So we will get here probability of A given B is same as probability of A. If A and B are independent, then probability of A given B is same as probability of A, and we know probability of A given B is this probability of A intersection B divided by probability of B. So probability of A intersection B divided by probability of B, this equals to probability of A. Now from here we will get probability of A intersection B is same as probability of A, multiply this probability of B here into probability of B. So remember this formula. In most of the questions we will apply this formula, or we will apply these two formula. These three formula are important for independence of two events. If in question it is asked to find that A and B are independent, we will show that probability of A intersection B is same as probability of A into probability of B. We will show this. If this holds, then A and B are independent. So let's start solving the questions. In question number 1, it is given that probability of A is 3 by 5 and probability of B is 1 by 5. Now find probability of A intersection B if A and B are independent. Given that A and B are independent, so we have to find probability of A intersection B. So first write what are the givens. So given probability of A is 3 by 5 and probability of B is 1 by 5. Now as A and B are independent, therefore probability of A intersection B is, we know probability of A into probability of B. So probability of A is 3 by 5, it is given in question, and probability of B is 1 by 5. So the final answer will be 3 by 5 into 5, 25. So probability of A intersection B is 3 by 25. So now see what is given in question number 2. So in question 2, it is given that two cards are drawn at random and without replacement from a pack of 52 playing cards. Find the probability that both cards are black. That means we have drawn two cards. From a pack of 52 cards. 52 कार्ड्स में से हमने दो कार्ड्स ले लिया, ठीक है. और एक इम्पॉर्टेंट चीज, विदाउट रिप्लेसमेंट, दिस इज इम्पॉर्टेंट. वी विल यूज दिस स्टेटमेंट. नाउ व्हाट वी हैव टू फाइंड द प्रोबेबिलिटी दैट बोथ कार्ड्स आर ब्लैक. नाउ वी नो आउट ऑफ 52 कार्ड्स वी नो 26 कार्ड्स आर ब्लैक. So let's write the solution here. Solution: given a pack of 52 cards, we know there are 26 black cards. Now let A be the event that first drawn card is black. card is black. Then what will be the probability of A? Probability of A will be, how many black cards are there? 26, and total card is 52, so it will be 26 by 52. Now again, let B be the events. Let B be the event that second drawn card is also black. Second drawn card is black. Now what will be the probability of B? Now see here, we will use the without replacement concept here. If A is occurred, that means we have drawn one black card. Then how many black card out of 26? If we have drawn one black card, then how many cards will be left? Will be left 25 black cards. So here we will write probability of B given A. That means A has occurred. We have drawn already one card. So probability of B given A will be how much? Total card is 25. 25 black cards out of 25 black cards. And how many cards? 52. Since we have already drawn one card, so it will be 51. देखिए क्वेश्चन में गिवन है 2 cards are drawn without replacement. टोटल कार्ड है 52. आउट ऑफ 52 we know 26 cards are black cards. Now if you drawn one cards that is black, then how many black card will be left? 25 black card will be left. अब हमने जो ब्लैक कार्ड लिया है वो रिप्लेसमेंट नहीं किया है, तो यहाँ कितने कार्ड बचेगा? 52 में से एक कार्ड हमने ले लिया, वो रिप्लेस नहीं किया, तो 51 कार्ड बचेगा. तो 51 कार्ड में से 25 ब्लैक कार्ड है. तो प्रोबेबिलिटी ऑफ बी गिवन ए, व्हाई गिवन ए? बिकॉज ए हैज़ ऑकर्ड. वी हैव ड्रॉन वन ब्लैक कार्ड, सो प्रोबेबिलिटी ऑफ बी गिवन ए. एंड हाउ मेनी ब्लैक कार्ड्स देयर? 25, and total card is 51. So this is 25 by 51. Now probability of A intersection B. Probability of A intersection B is probability of A into probability of B given A. So probability of A is how much? 26 by 52 into probability of B given A is 25 by 51. So it is 21s are 20, 26 1s are 26, and 26 2s are 52. So it is 25 by 102. हमने A intersection B क्यों निकाला? क्योंकि in question it is given that we have to find the probability that both cards are black. Both cards are black means A is black, B is also black. So we have to find probability of A intersection B, and we know the probability of B given A is probability of B intersection A is divided by probability of A. So what will be the probability of A intersection B? This probability of B intersection A and A intersection B both are same, is equals to multiply this here, probability of A into probability of B given A. Using this formula we have find this. So now let's see what is given in question number 3. So in question 3 it is given that a box of oranges is inspected by examining 3 randomly selected oranges drawn without replacement. If all 3 oranges are good, the box is approved for sale, otherwise it is rejected. Find the probability that a box containing 15 oranges, out of which 12 are good and 3 are bad ones, will be approved for sale. This question also have without replacement concept, so we will this. So first let me write what are given. Given a box of orange. Now let A, B and C denote the event respectively that the first, second and third orange is good. third orange is good. Now what will be probability of A? Now probability of A is means first orange is good. Now how many orange is good? It is given that good oranges in question 12 and total number of oranges 15. So probability of A will be 12 by 15. Now right here number of good orange, it is given equals to 12 and bad orange is 3. Now we have drawn one orange and that is good. So out of 12 how many good orange will be left? 11. So right here, since the second orange is drawn without replacement, so now the total number of good orange will be how much? 11, since we have drawn already one good orange. Also total number of orange is 15. Now if you have drawn one orange, then how many orange will be left? 14, right? And total number of orange will be 14. So therefore probability of B given A has occurred. So how many good orange are there? 11 and total number of orange is 14. So it will be 11 by 14. Again third orange is drawn without replacement. So we have drawn another good orange from this 11 good orange. So how many good orange will left? 10. So right here, so now total number of good orange will be 10 and total number of orange will be how much? We have drawn another orange from this 14, so total number of orange will be 13 and total number of orange will be 13. So now probability of C given A and B. So this will be how much? How many good orange are there? 10 and total number of orange is 13. So it is 10 by 13. Now we have to write thus the probability that all are good orange. The probability that all the orange are good. All the orange are good is probability of A intersection B intersection C, which is equals to probability of A into probability of B given A into probability of C given AB. What is probability of A? It is 12 upon 15. Probability of B given A is 11 upon 14 and probability of C given A is 10 by 13. So it is 5 2s are 10, 5 3s are 15, 3 1s are 3, 3 4s are 12, 2 2s are 4, 2 7s are 14. So it is 2 into 2 4, 4 into 11 44, 7 into 13 91. So 44 by 91. So right, hence the probability that a box will be approved for sale is equals to 44 by 91. Now let's see what is given in question number 4. So a fair coin and an unbiased die are tossed. Let A with the event head appears on the coin and B with the event 3 on the die. Check whether A and B are independents or not. First, let's write what is the sample space. What will be the sample space? A fair coin and unbiased die are tossed. So if you toss a coin, either head or tail will occur, and if you roll a die, then what will occur? Either 1 2 3 4 5 or 6. Out of this, any one can occur. So first let's write the sample space. Given a fair coin and a die is tossed, so if you toss a coin, then head may occur, and if you toss a die, then along with head 1 can occur, along with head 2 can occur, head and 3 can occur, head 4, head 5, head 6, or tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. This will be our sample space. Now what is given? A denote the event that head appears on the coin. Head appears on the coin. So what will be the outcome for this event? Head appears on the coin, that means head 1, this will be this 6 will come, head 2, head 3, then head 4, head 5, and head 6. So what will be probability of A? Probability of A will be, how many elements are there? 1, 2, 3, 4, 5 and 6, and in sample space how many are there? 12. So it is 6 by 12, that means it is 1 by 2. And in question it is given that B denote the event that 3 on the die. B denote the event that 3 on the die. So what will be the outcome for this? 3 on the die, that means this and this 2 will come. So head 3 and tail 3. 3 is on the die. So what is the probability of B? Probability of B is, how many elements are there? 2, and sample space is 12. So it is 1 by 6. Now to show that A and B are independent, we have to show that A intersection B is same as probability of A into probability of B. So we have to find intersection of A and B. So first let's write what is the intersection of A and B. So see, intersection of A and B will be only H3. See there, H comma 3 and H comma 3, these two are in the intersection. So only H comma 3 are intersection. So probability of A intersection B will be, how many elements are there? 1, and total is 12, so 1 by 12. Now check, probability of A intersection B is equals to probability of A into probability of B. And how much is probability of A? Probability of A is 1 by 2 and probability of B is 1 by 6. Probability of A is 1 by 2 and probability of B is 1 by 6. So that is 1 by 12. See, probability of A intersection B is 1 by 12, which is equals to probability of A into probability of B. So therefore A and B are independent. Therefore A and B are independent. Now let's see question number 5. In question 5 it is given that a die marked 1, 2, 3 in red and 4, 5, 6 in green is tossed. Let A be the event, the number is even, and B be the event, the number is red. Are A and B independent? So what will be the sample space? Sample space will be, a die is tossed, so sample space will be 1, 2, 3, 4, 5 and 6. This will be our sample space. So first write what is the sample space and what are the given in the question. So write the sample space is. So before proceeding further, I will request you to subscribe my channel and like and comment in the video. Also, if you need the handwritten notes of this video lecture, then you can let me know in the comments. I will share you the drive link from where you can download the notes of this lecture. So write given A be the event, the number is even, and B be the event, that the number is red. So what will be the outcome for A? The number is even. Even means 2, 4 or 6. So what is probability of A? Probability of A will be, how many number are there? 3, and total is 6. So 3 by 6, that means it is 1 by 2. So and what is the outcome for B? Event that number is red. See in question, the 1, 2 and 3, these 3 numbers are marked in red. So the probability of B will be, how many are there? 3 divided by total is 6. So this will be also 1 by 2. Now what is A intersection B? We have to find the A intersection B. A intersection B are only 2. See, 2 is here, 2 is here. So only 2. So what is probability of A intersection B? Probability of A intersection B will be, how many number are there? 1, only 1, and total is 6. So 1 by 6. So now check probability of A into probability of B. Probability of A into probability of B, how much? Equals to probability of A is 1 by 2 and probability of B is also 1 by 2, which is equals to 1 by 4, not equals to probability of A intersection B, which is 1 by 6. So therefore A and B are not independent. A and B are not independent. Now see question number 6. Let E and F be the events with probability of E is 3 by 5, probability of F is 3 by 10, and E intersection F is 1 by 5. Are E and F are independent? So you have to check they are independent or not. So these are given in the question. Now we have to check that E and F are independent or not. So to check E and F are independent, what we have to do? We have to do that probability of E intersection F, we have to show that is equals to probability of E into probability of F. This we have to show that if they are independent. So probability, what is the probability of E into probability of F? Probability of E into probability of F is 3 by 5 into 3 by 10, which is equals to 9 by 50, and 9 by 50 is not equals to probability of E intersection F. Probability of E intersection F is 1 by 5, which is not equals to probability of E intersection F. So probability of E intersection F is not equals to probability of E into probability of F. So therefore E and F are not independent. So in the next video we will solve the rest of the question. Thank you.